Yeah. So as mentioned, so the team is looking to designing the game in such a way that different types of items can be created automatically while the game is being played. So you advise the team that the abstract factory design pattern is a plausible approach since it allows for the efficient creation of different kinds of objects in real time, right? So they want to create different items automatically while the game is played. So you need to provide a UML diagram showing how the design pattern makes this possible. So the classes for the different kinds of objects that needs to be supported are shown in the form of Java code, right? So here are the classes. So we have our abstract factory interface, which basically has the produce water, produce rock, produce grass, produce ground. And then we have a concrete factory, which implements the interface. We don't have to know about the code inside of that, so we don't have to worry about it. And then we have another interface for the abstract product. So the only thing that an abstract product does that we care about is the fact that it initializes. And then we have a class which basically implements abstract product, and it basically has a method for animating. I'm sorry. Are you here for computer science too? Okay. So, and then we have a class called water, which extends extract item. And then we have another class called rock, extends item, grass, and ground, and so forth. All right. So basically, what we need to do is create a UML class diagram for the abstract factory design pattern. Okay. So let's open here. And let's just try to do this. So let's, I think this would be much better. So stop sharing and share that. Okay, so at the end of the class, could you please just remind me to generate an attendance code? Okay, so yeah, so let's just continue. Okay, so let's open, just bring Dia as well to the screen. Okay, so and then so let's just remind ourselves of the abstract factory design pattern. So abstract factory creational. Just bring it over here as well. Yeah, so yeah, so abstract factory have an abstract factory interface. We have a concrete factory, and then we have an abstract product, and then we have a concrete product, right? So we have to produce a UML diagram resembling this design pattern, right? So let's create our class. So remember, we have here, we have a class called abstract entity factory, right? So I'll just take this name as is. Paste it there. Then, so it's an interface. Here, and then, so make that apply. no attributes or operations. So I want to be able to produce all of these methods. So produce water, produce rock, produce grass, produce ground. So let's do that. Here, so, and wait, so not a void method. So let's just check. Oh yeah, so it returns an item, right? So let's just fix that. Okay, so strictly speaking, so here, let's just check something. Oh yeah, okay. Okay, so that's the factory. And then let's create the product. So that would be the abstract entity product. So every abstract product initializes. That's an interface. Operation, initialize. Okay, and then we have the item class, which implements abstract entity product. And this is abstract. And it has a method called animate. Okay, and then we have all of these classes that extend item. So this is a product. Yeah, so, and then we have also a concrete factory. So let's start with that. Concrete entity factory. So this will override all of the methods from the interface. Okay, so that's the concrete factory. Yeah, so try and zoom that in. Okay, so I don't know why it's doing that, but so I'm sure you guys get the idea. Okay, and then so we have all of the items. So obviously to override the animates method because it's abstract in the parent class. Yeah, so and then that's all the classes. So let's just do this. Bring these a bit closer. Then just do that. And then this one here. And then do the inheritance. So I really don't know what's going on with these controls. I have no idea. Okay, it's really doing behaving weirdly, so I'll just leave it like this. Okay, so that's the idea. And then we have all of that. And then so the entry, the factory creates an item. So there's a dependency relationship here. Like that. And then so then we have the client class. Okay, so that's the idea. So let's look at how you get the marks. So in terms of this, for classes and interfaces, you basically get a mark for the abstract entity factory interface. You get a mark for the abstract entity product interface. You get a mark for the concrete entity factory. You get a mark for all the classes. So the client class, you get a mark for that. Get a mark for the item class. Get a mark for the ground, grass, water, rock class. So all of that is 1, 2, 3, 4, 5, 6, 7, 8, 9 marks. And then just by having the classes. And then in terms of the class relationships, so concrete factory inherits from abstract factory, get a mark. And this implementation relationship as well, you get a mark. And then having these methods here, produce water, produce that, and all of that, get a mark for all of that. You get a mark for the initialize method. You get a mark for the animate method. And then you get a mark for showing that these override the animate method. Actually, these must override the initialize and the animate methods, right? So initialize and so forth. Yeah, so that's basically how they need to look. And that is your 15 marks. Okay, so let's move on to the next question. So let me just minimize that. Okay, so the code section. So this is the last question. Yeah, so here we need to basically create like a file handler class and method. So actually just a file handler method. So provide source code for the following problem. You can assume that all relevant packages have been imported. So we have Utopian Soccer Tournament. UST has finally come to an end. After the finals took place in Utopia City, now UST wants to provide fans with useful insights relating to the tournament. So the data for each game must be read into the analytics software. There are two types of games, group stage and knockout. And some of the code available is shown below. So we have a class called game, and then it has all of those attributes, and then it has a constructor. And then we have a class called group stage, which has that attribute, and it extends game, and it has that constructor. We have a class called knockout, extends game, has those extra attributes, and also has a constructor. So we need to create a class called get knockout games, and it must read a file as a parameter and return an array list of knockout games. So knockout games will always have an even game ID, right? So that's how we see that a line in the file is a knockout game. And the UST are trying to keep up to date with the advances in Java and requested that you use automatic resource management, right? So the formats of each game type is shown below. So this is a group stage format. That's a knockout format. So in our case, we only care about the knockout games. So we don't really care about uh, the group stage format. Yeah, so let's read in the data. So let me just check the mark allocation. Okay, so let's do that. Okay, so you can, for example, when you read this file, because it's a text file, and they gave you the formats of the data, you can use regular expressions, but because they didn't really tell you, like the restrictions for the data, like they didn't give you a sample, like data formats, right? Like the ID is 8 characters long, things like that. So the easiest way to do this is to just read in every line from the text file. What they gave you as a sign for determining what type of game you are reading is the ID, right? Because they're telling you that the ID is even, right? For every knockout game, the ID is even. So all you have to do is just read the whole line and then look at the first token. And then if it's an even number, then it's a knockout game, right? You don't have to do more than that. So then let's try and do that. Yeah, so we need to create a method called read game data, and returns an array list of game. Yeah, so we need to create the array list first. And then we need to use automatic resource management. And then taking the file. So that doesn't look right. Yeah, so that looks fine. Yeah, so what we need to do is read in each line of the file. And then we get the line. And then after getting the line, then we get the first token. And they told us that the format of the string is all of the values that are separated by commas. So comma, and then we get the ID. So how do we know the ID is an integer? Because it is an integer here. Okay, so yeah, and then after getting the ID, then we check that it's even. If we divide it by 2 and the remainder is 0, then it's even. And if it's even, then we read the rest of the line. So we now have the ID. The next thing we need to read is the time, and then participants, results, penalties, venue. Okay, so yeah. Just check if it's the right order. Participants, results, yeah, penalties, venue. Results. Penalties. And then the venue. Yeah, so we've read everything. So now we create the knockout. And it's the ID, time, participants, results, penalties, venue. And we add it to the array list. And that is that. Okay, so how do we get marks for this? So function prototype, get a mark. For taking the file handle, get a mark. For having the try block, get a mark. Creating a scanner, using automatic resource management, get a mark. Using the while loop and checking the next line, get a mark. Reading the next line, get a mark. Creating a string tokenizer, get a mark. Reading the ID, get a mark. Checking if it's even. Reading the rest of the line. So all of this, get 2 marks. And then creating the object, get a mark. Adding to the array list, get a mark. Catching the file not found exception, get a mark. Oh yeah, and then returning the data, get a mark. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's your 15 marks. Yeah, and then so that's basically the end of the SSA. Any questions regarding the SSA? Yes. You wouldn't lose marks, yeah. So that would be fine. Okay, and then any other questions? Okay, so no questions. Okay, so what we'll do is okay, so today is Wednesday, Thursday, Friday. Okay, so if you start another paper now, we can finish it by Friday, right? So let's rather do that. Okay, so let me just do this quickly. Let me just stop sharing momentarily. And just try to find the paper quickly. Okay, so let's find the special SSA, so triple SA. Where is this? Oh my word. Okay, let's do that. Okay, so let's share the screen again. Okay, so this is the special summative assessment. So yeah, so same stuff like in terms of the time allocation, 2 hours, 100 marks. Yeah. Okay, so let's start over. What is the difference between machine code and assembly language? What is the difference between machine code and assembly language? Okay, so the difference between the two is that machine code is basically ones and zeros, so it's just binary. It's purely numerical, no alphanumeric characters whatsoever. It's just binary, ones and zeros, right? So, and the binary numbers represent both data and the instructions, right? So the data is in binary, the instructions are in binary, right? So that's machine code, right? And then assembly language is that machine code instructions are represented by alphanumeric identifiers. So you have alphabets and all of that stuff. You have letters and numbers and symbols and so forth, right? You will learn about assembly language next year in Computer Science 3B. Yes. Yes, so machine code is much more lower level than assembly language. So that is a valid point. Yeah. So you need to make two points. So 1 mark per point. So you need to mention that it's binary or numerical, right? You need to mention that. You can mention that it's lower level than assembly language because it's true. And then you can also mention that it's the numbers are used to represent both data and instructions. Okay, and then also because, so in terms of assembly language, so you need to mention another 2 points. The first point is you can use alphanumeric characters. You can use letters and numbers to represent identifiers and data. Also, assembly language, because it's more high level than machine code, it's easier to use than machine code, right? So you can mention that. Or you could say machine code is harder to use than assembly language. You'd still get a mark for that. Yes. Assembly is? Yes, it is. So assembly language is, well, human readable is, I mean, it depends who you ask, but it is human readable, yes. Like generally, it's human readable. So that is fine. Um, Also, assembly code at the end of the day is converted into machine code so that it can be executed by the machine, right? So you can mention that as well. Any points that you mention among the points that we discussed is a valid mark. Okay, so question 2, discuss, wait, oh no, question 1B. So compare the Java and C++ programming languages. Your comparison must include only the differences between the languages. Yes. Can you repeat that? Yes. It's done by the programmer. Yes, that is true, right? So in Java, it's not really 100% accurate to say Java does not have pointers, but the pointer manipulation is handled by the compiler. So that is true. So in C++, you do pointer manipulation on your own. What else? So that's the one difference. What else? There's many. So in terms of the preprocessor, yes. Coding. Well, you would have to mention more detail than that, right? So just saying that it's better will not guarantee you marks, right? So you need to be more specific. So why is it better? So you can use, so let me give you guys clues, right? Yes. Yes. Yeah, so that is so yes. So I think a more like correct way of saying that is, so C++, like C++ code is compiled directly to the target platform, but Java code is compiled into class files, which can be run using the Java virtual machine. So that would be a mark. Yes. Yes, that is true. C++ uses namespaces. Java uses packages. That is a clear difference. Yes. Yes. Yes, that is true. C++ has structs. Java does not have structs. That is a valid difference. So you can mention that. Um, there's many other things. In terms of the preprocessor, does Java have a preprocessor? Can you include like hash include like preprocessor macros in Java? Right, so you don't have that in Java. In C++, you have preprocessor macros. In terms of, oh yeah, we already mentioned namespaces and packages, pointer manipulation, garbage collection. You know, Java does garbage collection for you. C++ does not do garbage collection. Exception handling. C++ does not have checked exceptions, right? So it doesn't force you to do exception handling. Java has checked exceptions, so that's also a valid point. Inheritance, this is a big one, right? C++ supports multiple inheritance. Java does not support multiple inheritance, right? So you need to use interfaces. Yes. Yes, that is valid. But so you need to. So what did you want to say after that? Yes. So C++ in terms of speed is generally faster than Java, right? Yes, because you have to run it using a Java virtual machine. Yes, that is true. Yeah, so multi-threading as well. C++ uses third-party libraries for multi-threading, strictly speaking. Java has multi-threading built in. In C++, a class can be stack allocated, right? In Java, all classes, all objects are heap allocated, right? So if you want to create a heap allocated object in C++, you have to use the new keyword, right? Or rather, not just a new keyword, but you have to like create your class using a pointer. So like a pointer to an object. Then it will be allocated onto the heap. But in Java, as long as you create an object, it's automatically heap allocated, right? So there's a lot of stuff. In C++, a string is a char pointer. In Java, a string is a string, right? There's the string class, right? So all of those things. Okay, so you mentioned any 6, and then you get your marks. Discuss when you would use continue instead of break. So let's see the answers on Blackboard. Okay. Oh yeah. Okay. So when would you use continue instead of break? You use continue to end. Yes. And when do you use break? Yes, that is true. Yes. Do you want to add? Yes.
You say find something, then break. While continue, maybe be excluding something, right? So let's say you say, for instance, something like this one.
Yes.
And you say continue. So would that get appropriate response? Because that's not application response. That's saying continue, skips the iteration.
Yes. So yes, so you would get a mark for that as long as in your answer. So even if your answer is application based, as long as your answer still has the fact inside of it, right? The fact is that continue skips the current iteration. So even if you're in your answer, you say you're searching for something, but like the thing you're searching for, you haven't found it, so you want to skip to the next element, then that's fine because it still means that you are skipping the current iteration. That's the most important thing. And then break terminates the loop, right, altogether. We're actually out of time, so we're going to stop here. We're going to continue tomorrow. On Friday, we'll definitely finish this paper. Thank you very much. Here's the attendance code quickly. Just do this. So this is for the class campus. So just do this quickly. Okay, it looks like there's going to be another class. So I'll just post it on Discord. Okay, so you know what? If you attended this class and you are here now, send me an email within before the end of the day. So just say I attended class today. Thank you.